Question 39. Q is a compound that forms a gas when added to aqueous sodium carbonate. What is true about Q? So the only reactant that can react with a carbonate to form a gas is an acid. In this case, the acid reacts with the carbonate to give off carbon dioxide gas. So Q must have been an organic compound that is an acid, and from what we know, that has to be a carboxylic acid with a COOH functional group. Option A states that Q can be formed by reducing ethanol. This is wrong because carboxylic acid can be formed by oxidizing alcohols, not reducing. The reverse reaction to form alcohol is the reduction of carboxylic acids. Therefore, A can be eliminated. Statement B states it could form an ester with ethanoic acid. Again, being an acid, it will not react with another ethanoic acid to form an ester. To react with an ethanoic acid to form an ester, Q has to be an alcohol, but Q in this case is a carboxylic acid. Therefore, B is also eliminated. C states it could have the empirical formula C2H4O. We know that every carboxylic acid should have at least 2 oxygen in the carboxylic acid functional group. So having an empirical formula of C2H4O means that this is the simplest ratio of all the 3 elements present. Let's try to multiply the entire molecule by 2 to get at least 2 oxygen that is present in the compound. This gives us the molecular formula of C4H8O2. With 4 carbon, C4, and then carboxylic acid at the end, filling in all the other hydrogen on the remaining 3 carbon atoms, we see that indeed we have 4 carbon atoms, 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms and 2 oxygen atoms. And this in turn gives us the empirical formula C2H4O. This is indeed a carboxylic acid, which is specifically butanoic acid, since there are 4 carbon present. Therefore, C is correct. Option D states that it could have molecular formula C2H4O. So the molecular formula states the exact number of the elements present in one molecule. Let's draw out an acid with 2 carbon atoms. Since there are 2 carbon atoms present, we should be drawing the structure of an ethanoic acid. Filling in the 3 remaining hydrogen on the other carbon atom, we see that this compound has a molecular formula of C2H4O2. This molecular formula does not tally with this molecular formula. Hence, this formula given is not that of an acid, specifically ethanoic acid with 2 carbons. Therefore, option D can also be eliminated, leaving us with C as the correct answer.